All right, here we go. So this is section 3 of the Algebra 1 MCAP test, and I want you to, there's 6 questions, so you're going to get like 40 minutes, and if you don't prepare and you don't know the questions, you just have to bubble and answer. You could be done in 5 minutes, or you could be done in 45 minutes if you're really trying, right? So let's see what we got here. John has to type a 2,000 word business. I see a y-intercept right there. I don't know what you guys see. Looks like a y-intercept. And he types at a rate. I see a slope. So now I'm sure it's a y-intercept. The function r of m equals 2,000 over 40 minus m can be used to calculate the number of minutes required to finish. So m minutes. So m is minutes, and then r is, what is r? What is the domain of the function r? Oh, so words. He types at a rate of, okay, yeah, words is, so it's y, x, or you know, m. Okay, so this is words, and then m is minutes. You type in, all right, so it says, okay. What is the domain of function r in this context? So it looks like it takes him 50 minutes. Is that right? So what's 2,000 divided by 40? 2,000 divided by 40 is 50. So it's going to take him between 0 and 50 minutes to, to finish. 1 second. Ooh, I was looking at the answer key for section 2, and I was like, how did I get that wrong? But we got it right. It's B. Okay. And that's what we put. Moving right along. The company sold a total of 150 adult and child tickets. So right away when I read that, I see I see X and Y. Do a fundraiser. A total, and then the total tickets. So that's X plus Y equals 150. The company charges $10 for each adult ticket. Okay, so that's 10X. $6 for each child ticket, 6Y. If we add those together, we have a total cost somewhere. I don't see a total cost. Okay, which equation represents the relationship between the number of adult tickets and what? All right, so the number of tickets. Oh, it's very interesting. So the total of, so I'm looking for X plus Y equals 150. Which equation represents the relationship between the number of adult tickets raised from the sale of tickets? All right, let me pause this. I got it. All right, so this one was a thinker. So this is my original, brainstorm, but it doesn't mean that it helps us answer the question all the way, but it does get us started, right? So the only thing is they said that the number of adult tickets is X. Oh, but I said that too. So then we have 10X, right? And then X plus Y. So if we rewrite this in terms of adult tickets, we would have 150 minus Y. Well, Y equals 150 minus X. So I'm thinking that the adult tickets are 10X. We know that for sure. And then the child tickets cost 6. And then how many child tickets are there? Well, there's 150 total tickets. subtract the number of adult tickets, and so that is the number of child tickets sold. So that is why and then y would equal the total cost. So this was a tricky one, but the answer is D. And how can we be sure about that? Because we know the coefficient of x should be 10, because that is the price of adult tickets, and adult tickets is x. Also, we know that the child tickets is 6, and the total child tickets is going to be 150 minus the adult tickets. And y is the dollars. So if we multiply those two together, we would get the total dollars. So I'm pretty confident that number 2 is D. There we go. All right, any questions? Just ask about it. All right, the quadratic function f is defined as f of x equals negative. Hey, vertex form again. I feel like it's deja vu. All right, so let's write that vertex form. Consider the graph of f of x in the xy plane. State whether there is a possible transformation. Okay, so of f in the form g of x equals f of x plus k, where k is a constant, a number, for which the graph of y equals g of x will have no intercepts. Justify your answer. You enter your answer in the space provided. State whether there is a possible transformation of f in the form g of x equals f of x plus k, where k, that would have no intercepts. So, all right, a lot of weird wording, right, that you probably makes you uncomfortable. But now that I've read it entirely, I see that this is saying vertical shift. And then this is saying horizontal shift. And we know in vertex form that the horizontal is right there and the vertical is right there, right? So is there a way, and so we're talking about no x-intercepts. So right now, this graph opens down because of the negative in front. It has a vertex at -2, +3. So it looks something like that, right? And we want to know, is there a vertical shift that would make this have no x-intercepts? Yes. If we shifted down, more than 3, so maybe 4, right? So shift down 4, which means k equals -4. And that would be a possibility. And then how about if we shift it to the right or to the left? Could we make it not have x-intercepts? The answer is no solution. Left-right shift will not take away the x-intercepts. All right, so be confident in your knowledge and use everything you know to get these answers here. Because you're going to have 45 minutes to do the 6 questions, so just keep thinking about it. Make sure you have a good pace. The XY plane shows a graph of the solutions to a system of inequalities. So we know about that. We got dotted lines, so that's less than or greater than, no or equal to, and shaded over there, that must be the overlapping of the 2 lines. So systems of inequalities. If A and B are positive integers, the system consists of which inequalities? Okay. So this graph it has an intercept right here, and it has a positive slope. So AX, so B is a positive integer, so that means minus B, right? So this is, and we know that we're less than this line, so that would be less than AX minus B. And then this line here is going down, so it's negative AX, and it has a positive y-intercept plus B. And the shading is above, it's above this line, so that would be greater than. So I'm going to look for y is less than AX minus B, and y is greater than negative AX plus B. Wow, and they gave me just all the options, so less than AX minus B. And y is greater than negative AX plus B. I've got it. All right, moving along. Checkmate. For each 1 year period after a car was purchased, I'm seeing percentage, I'm seeing exponential. I'm seeing a lot of exponential questions on this test. Sad. Very powerful function. All right. For each 1 year period after the car was purchased, its value at the end of the year was 15% less than at the beginning of the year. So our growth rate is 15. Well, our growth rate is, we're subtracting 15. So 1 minus R, so 1 minus 0.15 equals 0.85. So this is our decay factor. So if you know that you're decreasing, take that percentage and subtract it from 1, and you're going to get your decay factor. Also, when you notice it's exponential, make sure you write A times B to the X. This is your y-intercept, your initial value. This is your growth / decay factor. And your growth rate, 1 plus minus R, is the growth. Okay, so that's the growth factor, but R is called the growth or decay rate. So make sure you know what you got. Okay. State whether the value of the car is a function of time after it was purchased is best modeled by exponential. Because there is a decrease in percentage growth each year, giving a decay factor 15% decrease each year of 0.85. All right, if the value of the car 2 years after its purchase was this, what was the value of the car when it was purchased? Wow, that is a toughie. Okay, all right. So we know we have a 0.2, 17, 9, 18, right? And we also know that we have y equals a times 0.85 to the x. And so in this case, we can substitute 2 and 17.17,918 into this formula. So we're going to get 17,918 equals a 0.85 to the second. So let's go ahead and square 0.85 squared is 0.7225. So a times 0.7225 and now we just divide both sides by 0.7225. Boom. And a equals 17,918 divided by 0.7225, 24,800. Ta-da! Look at that. Just a little bit of Algebra 1, and we've got our answer. A very interesting problem. This part 3 is going to trip some people up, but not you, because you're going to prepare, right? A ball is hit from the ground. Parabola, quadratic, we're hitting a ball. Going in there, projectile motion. When the ball traveled a horizontal distance of d meters, its height was h meters, can be modeled by the function. There it is, quadratic function degree 2. What is the horizontal distance, that's a x, when the ball lands on the ground? Come on now, that's the x-intercept, right? Well, this is a great opportunity for us to use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You know? So a equals negative 1 over 125 and b equals 1 and c equals 0. So we're using the quadratic formula because that formula gives us our x-intercepts, that or solutions to the equation. 0 equals. So let's go ahead. So we're going to have negative 1 plus or minus the square root of 1 squared minus 4 times negative 1, 125 times 0 all over 2 times negative 1 over 125. Okay, so that's multiplied by 0, so that's gone. Negative 1 plus or minus the square root of 1 squared. And then what is that? 2. Let me do that over the side. 2. Negative 2 over 125. Oh, okay. So negative 2 over 125. And so negative 1 plus or minus the square root of 1 squared is just 1. So negative 1 plus or minus 1 over negative 2, 125. So negative 1 plus 1 is 0. So that one of our x-intercepts is 0. But negative 1 minus 1 is negative 2 over negative 2, 125. So let me just do that over here. So negative 2 divided by this thing, negative 2 over 125 is equal to negative 2 times 125 over negative 2. And so that just equals 125. Wow. So the horizontal distance when the ball lands on the ground is 125 meters. Interesting, huh? Let's check that. 125, you can see it through the text. There it is. Hey, Mr. Field, good job. Good job, Mr. Field. All right, so that is the end. Is that the end of? Stop. All right, let's stop. Stretch out before section 4.